See Lindelof videos, AP Calculus, change of variables for definite integration. In this one, we're actually going to evaluate the definite integral here, but I want to use this rule. There are two ways to do this, and either way works fine, but I wanted to demonstrate the use of this rule and when it can be applied. So the rule just says that if I have the definite integral a to b of f of g of x times g prime at x dx, I can use u substitution and evaluate that without resubstituting in my x values by saying that it's going to be the definite integral from g of a to g of b. That's where these two things come from. Of f of u du, remember that we're going to say that u is equal to g of x. So here's a problem that we worked on yesterday, but I didn't do the substitute. I did the resubstitution. Here I'm not going to. I'm actually just going to leave it the way it was. And it's negative 3 to 0 of opposite 8x over 2x squared plus 3 quantity squared dx. And the author assigned us this u value of 2x squared plus 3. So again, look at what we have here. The first thing I'm going to do is this. I'm just going to start doing my u substitution. My u substitution, it says u is this, so I can just take this out of here and put in u, can't I? So there's u. Hopefully you can see the problem here. And the problem is simply that now we have an integral in terms of more than one variable. So that's a mess. We have x. So that's a problem. So I'm going to try to clean that up a little bit. And I'm going to take the derivative of u, which is du dx, derivative of u in terms of x, which would just be 4x, wouldn't it? I'm going to solve a little bit more and say that dx, through a little bit of algebra, is du over 4x, isn't it? So I'm going to substitute some more. Actually, I'm going to rewrite this so you can see it more clearly. Say, okay, have the definite integral from negative 3 to 0 of opposite 8x over u squared. And now what I'm going to say is that dx, this dx is this dx. Dx is that, so is du over 4x. Hopefully you can see that I replaced dx with its equivalent. That was okay. Here I'm going to simplify this thing out a little bit. When I simplify this, 4x goes to 1, doesn't it? This x cancels and this goes to 2. Are we in agreement here, I hope? So now we should have the definite integral from negative 3 to 0 of opposite 2u to the negative 2, isn't it? du. Now, this is what my intention was yesterday. My intention yesterday was to go back and resubstitute in, to take u out and resubstitute in the x values. Therefore, I didn't change this. However, that's not my intention here. I'm going to show you the other way to do it. So what I'm going to do is I'm going to set up this definite integral. This negative 2 is this one. Right, this negative 2 is this one. No, you know what? I'm going to leave it just like that. Negative 2u to the negative 2 d. I'm going to leave it like that. But what I'm going to do now is this. I need not negative 3, but g of negative 3. And remember that the g value was 2x squared plus 3, so 2x squared plus 3 of negative 3. So we have negative 3, so we have 2 times negative 3 squared plus 3. Negative 3 squared is 9. 2 times 9 is 18, so 21, right? So 21 here. And at the top, we'll have of 0, which will be 2 times 0 squared plus 3 is 3, isn't it? Now I have to integrate this. So when I integrate this, I'm going to get negative 2 times u to the negative 1 over negative 1 as evaluated from 21 to 3, right? This negative and this negative cancel, so I have 2 u to the negative 1 is over u, right? As evaluated from 21 to 3. So I'm going to take f of 21, so 2 over 21 minus 2 over 3. I can make this into 21st by multiplying by 7, can't I? So it's the same as 14 21st. 14 21st. All right, will give us 12 21st. And 12 21st is, let me see, this goes into, 3 goes into this 4 times, 3 goes into this 7 times, is equal to 4/7. And there's our answer using U substitution. What I'm saying to you now is if you went back and did it the other way, if you went back and substituted the U value back in and did it the old way, it would come up to exactly the same answer. So hope this was helpful. Thanks for watching. Any questions or comments, let me know.